What if you met another version of yourself? It's a quiet thought, isn't it? But a powerful one. I don't mean a twin or some stranger who just happens to look like you. No, I mean truly another you. Someone who has lived your exact life, shared your memories right up to a certain point. And then their story diverged. The idea is just so alluring. We see it in stories all the time, the doppelganger, the other self from some parallel world. And I think it taps into this really deep human curiosity about the paths we didn't take, the other lives we could be living right now. But the moment you try to pull this idea out of fiction and into the real world, well, it stops being a simple story. It forces us to bump up against some of the deepest, most difficult puzzles in all of modern physics, and it makes us question what it even means to be a self in the first place. And it's totally natural if all of this feels confusing. Honestly, pop culture treats the multiverse like some kind of cosmic playground, right? Where jumping between worlds is as easy as walking through a door. But the reality, the one hinted at by physics, is so much more intricate, and I think so much more profound. This can feel a little intimidating, but I promise, once you see what's actually going on, it becomes a lot clearer. You know the tropes, swapping lives to fix a mistake, meeting your evil twin. It's all presented so casually, as if a universe is just another place you can book a trip to. But the questions that physicists and philosophers are asking are, well, they're on a whole different level. Things like, what are these other worlds physically? What's the barrier keeping them apart? And the big one, who or what are you in this immense branching reality? So to figure this out, we're going to take a little journey. First, we'll look at the many worlds reality itself. Then we'll examine the wall between those worlds. After that, we'll try a thought experiment, a trans-universal swap, and see how that leads to the idea of you splintering apart. And finally, we'll land on a new way to think about what it means to have a universe all your own. Okay, so let's start at the beginning. The idea of another you, it's not just make-believe. It actually comes out of one of the most serious, most debated ideas in all of quantum mechanics. So, back in 1957, a physicist named Hugh Everett III came up with a really radical solution to a really weird quantum problem. See, down at the tiniest scales, particles don't seem to have definite properties until you measure them. Everett's idea, which we now call the many worlds interpretation, was this. What if the particle is actually doing all the possibilities at once? And when you make a measurement, the universe doesn't just randomly pick one outcome. Instead, it branches. Every single possible outcome gets realized, each in its own brand new separate parallel world. So, how does this actually happen? Well, it starts with something called superposition. That's where a quantum system is just a wave of all its possibilities at once. Then, some kind of interaction happens. Could be anything, even a single photon of light bouncing off an electron. That interaction forces a choice, and at that exact moment, the universe unravels. The thing to remember here is that worlds aren't being created out of thin air. They're being separated from this unified web of possibilities. And once they're separated, they're isolated. They can't talk to each other anymore. And the scale of this is, well, it's just mind-boggling. The physicist Bryce DeWitt put it beautifully. He said this isn't some rare thing happening in a lab. No. Every quantum transition taking place on every star, in every galaxy, in every remote corner of the universe is splitting our local world on Earth into myriads of copies. Just think about that. A near infinity of worlds, constantly branching off from ours every single moment. Now, that immediately brings up a huge question. If all these countless versions of our world are popping into existence all the time, basically in the same space we're in, what's keeping them apart? Right? Why don't we feel these splits? Why can't we see or wave to these other realities that are supposed to be all around us? There has to be some kind of barrier, some physical process that's keeping everything separate.
And there is. That process is called quantum decoherence. A quantum system can only stay in that neat, wave-like state of multiple possibilities as long as it's perfectly isolated. The second it interacts with its environment, a stray air molecule, a bit of radiation, anything, that beautiful, coordinated relationship gets completely scrambled. It's like, imagine perfect, clean ripples from one pebble dropped in a still pond. Decoherence is like throwing 1,000 more pebbles in at once. It turns those clean ripples into a chaotic mess.
So, to put it simply, decoherence is the wall. Once the quantum states of two branching universes have decohered, they just can't influence each other anymore, at all. They can't interfere. For you and me, they are now completely separate realities. And as far as we know, with the physics we have today, Traveling between them is impossible. But this is where it gets interesting. For the sake of our journey, let's just pretend. Let's do a thought experiment. Let's imagine we could build a machine that could somehow bypass decoherence and let us do a swap. What would the universe have to say about that? So we're going to set aside that one massive obstacle just for a moment to see what other, maybe even deeper challenges are waiting for us. If you could, right now, trade places with the you from a parallel world, what would you find? Now, even though we're focusing on the many worlds idea, it's worth noting there are other multiverse theories out there. But you know what? It doesn't really matter which one you pick. The challenges you'd face trying to swap places would be pretty much universal, starting with the very laws that govern reality. The very first and most instant threat to your survival is that the fundamental constants of nature, the things that make the universe tick, might be different over there, and our entire existence depends on those numbers being balanced on a razor's edge. I mean, just look at this. The fundamental forces that hold our universe together are perfect. They're perfectly tuned for life to exist. If gravity were just a tiny bit different, stars either wouldn't form at all or they'd burn out way too fast. The smallest tweak to any of these constants, and you'd have a universe where something as complex as you, well, you just couldn't exist. Period. Okay, but let's say you get incredibly lucky. You land in a universe where the laws of physics are identical to ours. Great! The next big problem comes from inside your own body, because even on a world that looks exactly like Earth, the biology could be completely, fatally alien to you. Take something called molecular chirality. A lot of complex molecules, like the amino acids that make up your proteins, can exist in two forms. They're perfect mirror images of each other, kind of like your left and right hand. Chemically the same, but they're spatially opposite. Now, all life that we know of in our universe uses only left-handed amino acids, but it's totally plausible that life in another universe evolved using the right-handed kind. If you arrived there, you could eat all the food you wanted, but your body's enzymes wouldn't know what to do with it. You'd literally starve to death in a world full of food. And that's just the start. You'd be facing countless other invisible threats. You'd have zero immunity to their germs, and the bacteria you carry around every day could be a deadly plague over there. The whole ecosystem, which is the product of a totally different history of evolution, could be toxic to you in ways you couldn't even imagine. But let's keep pushing this thought experiment. Let's imagine you survive it all. The physics are the same, the biology is compatible, you've made it. But now you face the biggest challenge of all, one that gets to the very core of who you are. Because, think about it, after the swap, there are now two of you. There's one of you, here, in this new universe, and there's the other you, back in your old one. Both of you have all the same memories right up to the second you swapped. Both of you feel, with 100% certainty, that you are the real continuous person. So, who's right? There was a philosopher, Parfit, who thought about this a lot. He came up with a thought experiment called fission. Imagine you, the original, are perfectly duplicated. Poof, now there are two of you. Both of these new people have all of the original's memories, their personality, everything. But here's the catch. Identity is a one-to-one thing. You can't be the same person as two separate people. So Parfit's conclusion was startling. The original person is simply gone. They've ceased to exist, and they've been replaced by two new successors. If we apply that logic to our scenario, the universe swap isn't just you moving from one place to another. It's an act of fission. The single continuous thread of your existence has been cut. The you that stepped into that machine is gone, replaced by two new people, each carrying a piece of your life forward in a different universe. You know, this idea has kind of haunted us for a long time, way before quantum physics. The novelist Dostoevsky wrote about a man tormented by his exact double, and he said, "Either you or I, but both together is out of the question." The very existence of the other one challenges your own unique claim to being you. It's really the ultimate uncanny valley, isn't it? The thing that's so disturbing isn't some monster. It's a perfect reflection of you that breathes on its own. It threatens your sense of self, your uniqueness, the entire story of your life. To meet your double is to have your own existence thrown into doubt. So after this journey through physics and biology and philosophy, we've arrived at something deeper. We started with what seemed like a simple question about travel, but what we've really uncovered is something much more fundamental about ourselves. You see, the real problem isn't how hard it would be to bypass decoherence. It's not the danger of different physics or alien biology. It's not even the paradox of a splintered identity. All of those things, they're just symptoms of a much deeper truth. The real issue is that the question itself, what if you swapped universes, is built on a mistaken idea. It assumes that a self is like a portable object, a piece of luggage that you can just pick up and move from one reality to another. But what if that's not what a person is? Not at all. You are not an object in the universe.
You are a pattern of the universe. An object can be moved. A pattern can't. You know, a wave isn't an object in the ocean. It's a pattern of the ocean itself.
Think about it. You are woven into the very fabric of your reality. The atoms that make up your body, they were forged in the hearts of stars from this universe that died billions of years ago. Your biology is the end result of billions of years of evolution that happened on this specific planet. Your memories aren't just data. They are a physical record of a timeline that unfolded only in this unique version of space-time. Your consciousness itself is a property that emerged from these particular laws of physics. You are inseparable from your universe. Trying to pull you out of it is like trying to pull the plot out of a book. Whatever's left, it's just not the same thing. And that brings us to a final thought. What if that wall between worlds, the fact that the swap is impossible, what if that isn't a cosmic prison? What if it's the very thing that makes your life, well, your life? Maybe the fact that you can't leave your universe is the ultimate proof of your singular, unique, and totally irreplaceable existence, right here in this one. If this way of looking at physics made sense to you, there are more journeys like this one on the channel. Thank you for your time and for your curiosity.